Hi friends, welcome to the Unit 3 Day 3 notes. This one talks about the rational zeros theorem. Rational zeros theorem is essentially a way to look at a polynomial and say these are the possible rational zeros. These aren't guaranteed, these are possible rational zeros. And we can do that because of some values that we know to be true for all polynomials that have integer coefficients. Notice that this example here, it has integer coefficients. What we need to pull from this is the constant term, which is p, and then q is your leading coefficient. So for this one, my constant term is 4, my leading coefficient is 8. So p over q means that the possible rational zeros of this are going to be all the factors, all the factors of 4 over all of the factors of 8. The factors of 4 are plus and minus 1, minus 2, and plus or minus 4. It is important to note the plus or minus component for these because you can have both positive and negatives. If I list these out, again, I'm dividing. Think about if I'm dividing these. My smallest value, or my value closest to 0, that's my value closest to 0, 1 over 8 is going to give me, out of all of these fractions that I'm dividing, remember I'm dividing these to get the factors, if I divide all of these, 1 over 8 is my one closest to 0. So that's the one I'm going to list first. Then 1 out of 4, 1/4, again plus or minus. Need to make sure I include that. I apologize. 1/2. Now, you also see that 1/2 will appear in other ways as well. If I take 2 out of 4 or 4 out of 8 and I reduce those, I'm going to get 1/2 also. I'm not going to be listing it multiple times. So be careful, as some of these will appear multiple times. 1/2 and then plus or minus 1. And then now I have plus or minus 2, plus or minus 4. A lot of students will make a mistake and try to get a scenario because 8's your denominator, not your numerator. So this accounts for all of the scenarios from mentioned above. If you find another situation, you'll see that it reduces down to those. So these are all of the possible rational zeros. That means there are no other possible rational zeros for this polynomial except this. That doesn't mean that there are complex zeros or irrational zeros. So those exist also. In fact, the fundamental theorem of algebra says every function defined by a polynomial of degree 1 or more has at least one complex zero. Now, that complex zero could be 0. So the complex value for it could be 0, but it has at least 1. And the reason we say that it has at least 1 is because it has to also satisfy the number of zeros theorem. If it has a degree n, it has at most n distinct zeros. So when we talk about multiplicity, from the previous page, really what we said is that it's a zero of that multiplicity of that many times, and it tells us what's happening to satisfy this number of zeros theorem. And if we have a complex zero, then we know that the conjugate, remember the conjugate is when we take the opposite of the complex part, and that is also a complex zero. So in this next video, we're really going to jump into finding the function and identifying the polynomial if I'm giving those zeros. Note for this first one that you just have integers, but for the second one, we're starting to get into multiplicity and some imaginary numbers. I will see you in the next video.